Hi friends, this is Hari Babu, Department of EEE, Chebrool Engineering College, Chebrool. The subject I am going to deal is network analysis. The Unit 1, Introduction to the Electrical Circuits. In the previous video, we have completed the basic definitions topic, and coming to the next topic, network classification. Topic 2, classification of network parameters. There are mainly four types of network parameters are there. The first one is active and passive elements, linear and nonlinear elements, bilateral and unilateral elements, lumped and distributed elements. Right. Coming to the first topic, first classification of network elements. First topic is active and passive elements. So what is meant by active and what is meant by passive? The active elements, the elements those which are deliver the energy is called active elements. That means voltage source and current source. Examples are voltage source and current sources are the sources which deliver the energy. Okay, so the representations for voltage source is like this, and the representations for current sources are like this. So the active elements are those which are deliver the energy, only delivers the energy only. Okay, right. Coming to the passive elements, the passive elements are those which are receives the energy, delivered by the active sources. For example, resistance, inductance and capacitance. These are the examples for passive elements. These resistance, inductance and capacitance are the passive elements which can receive the energy. Okay, I mean that these like loads, right? Loads, that is nothing but appliances. In households we have some appliances which receives the energy delivered by the sources, that is voltage source and current sources, right? So active elements and passive elements. Active elements are those which deliver the energy, passive elements are which receives the energy, right? So the example for active elements are voltage source and current source. The passive elements examples are resistance, inductance and capacitance, right? Coming to the next topic, that is linear and non-linear elements. So linear elements, we know that in the previous years we discuss or learned that about linear elements. What is meant by linear means the characteristics are straight line passing through the horizon, right? Here also I mentioned the same thing also, that is the element is said to be linear, that is the elements, linear and non-linear elements, the element is said to be linear, the voltage and current characteristics are straight line passing through the horizon, right? So here I taken a small figure, that is these are the characteristics for voltage and current. Voltage and current characteristics are straight line passing through the horizon. So the element for this is linear. We have another definition also in the network analysis actually. So the main definition we need to consider only this one actually. If the VA characteristics, these VA characteristics are satisfies the principle of superposition homogeneity principles, then it is called linear actually. Okay, superposition and homogeneity principles, which the characteristics those which satisfies the superposition and homogeneity, then it is said to be linear. Which does not satisfy the superposition and homogeneity, it is called non-linear, right? If the characteristics are not satisfy the principle of superposition and homogeneity principles, then it is called non-linear. For example, so I have taken some other parameters actually, that is a P and R. Actually the characteristics are like this. Okay, so the characteristics are non-linear. Actually this is non-linear, it is not a straight line. Okay, it is not a straight line, that's why it is non-linear elements. The example for non-linear elements is this one, and the example for linear elements is this one. Okay, it is a straight line passing through the horizon, it is not a straight line. Okay, right, that is non-linear and this one is linear, right? Coming to the next parameters, that is bilateral and unilateral elements. Very important. First one I need to define the elements for bilateral elements. So the element is said to be bilateral, its VA characteristics are same either the direction. Okay, Either the direction means here I taken small characteristics, that is voltage and current. Here actually the four quadrant operation, voltage plus voltage, and this is minus, this is positive, and this is negative, right? We already know that. The characteristics for drawing for some element, that is element, this is element, let's say the element characteristics are like this, that is VI characteristics. Okay, so I mentioned the definition is this VI characteristics are same either the direction, either the current direction actually. Okay, now we can mention this, it is a current direction. Okay, now I mean that it is a positive direction, the current positive direction, and this is negative direction. Okay, the characteristics of V and I, here also V and this is I, the same characteristics are appear here also. Otherwise this is the first quadrant and third quadrant lo we have presented here same characteristics, right? So I definition also here, the VA characteristics are same either the direction, means whether the current passes through a positive direction, the current passes through the negative direction, the characteristics are same. So coming to the unilateral, we can that is the element is said to be unilateral, its VA characteristics are not same either the direction. Either the direction means either the current direction, right? Here I draw a VA characteristics separately. So this is in the first quadrant actually VA characteristics are linear like this, and the third quadrant the VA characteristics are like this. So here I mentioned in the first quadrant and third quadrant the characteristics are not same. Okay, right? In the positive direction of current the characteristics are like this, in the negative direction of current the characteristics are like this, both are different. So it is said to be linear, right? These characteristics are said to be unilateral, right? Unilateral and also non-linear. Okay, right? Coming to here, this is bilateral because it is said to be the VA characteristics are same either the direction, current positive direction, and here the current in negative direction, the characteristics are same in the both the cases, but here it is not same in the both the cases, right? So that's why this is a bilateral element and this is unilateral elements, right? Okay, coming to the next last one, lumped and distributed elements. Lumped elements, the lumped elements are those which are small in size and which can analyze separately, right? Nothing but the examples for lumped elements are resistance, inductance, and capacitance. Okay, right? What is meant by lumped elements? Clearly lumped elements are those which are small in size, so the size of the lumped elements are small and which can analyze separately. The point is which can analyze separately. Just I said here this is a capacitor, okay, this is resistor and this is inductor. Okay, we can analyze actually this is resistor and this is capacitor and this is inductor, right? We can analyze separately, but in case of distributed elements it is not possible. That is the definition for the distributed elements is the elements are those which cannot analyze separately, cannot analyze separately means the example for this transmission line. Okay, the example for this transmission line. So here I am taking this transmission line. We know that the nearby highways or nearby roads we regularly see is this one. So I have taken one conductor in the transmission line. This is one conductor. So the conductor itself, his characteristics has resistance, inductance, and capacitance, but we cannot separately analyze. Okay, but we cannot analyze separately, but its characteristics we have resistance, inductance, and capacitance also. We have resistance, inductance, and capacitance also, but we cannot analyze separately. But in case of lumped elements we can analyze separately. This is resistor and this is inductor and this is capacitor. Okay, right? That is about lumped and distributed elements. So coming to the last, I have taken a small question for the following characteristics. Classify the elements. So first one, this is the characteristics for some VI, let us say VI. So what do here is this active element or passive element, or is this linear or non-linear, or this is bilateral or unilateral? Let us discuss. Okay, right? So here I already know that is this first one is active and passive, right? So active elements are those which deliver the energy, but here the characteristics are element is receives the energy, right? So clearly and blindly we can say that in the first and third quadrant we can mention this is passive, okay. And coming to the linear and non-linear elements, is this linear? It is a straight line, or on the not straight line? So it is not a straight line, that is you can blindly say that non-linear. Is this bilateral and unilateral? Let us say the characteristics are same, either the direction means the characteristics in the positive direction is like this, and the negative direction also same, okay, right? Same characteristics are appear in the positive direction and negative direction also, so then it is said to be bilateral, okay. The characteristics for this element is passive, non-linear and bilateral. Coming to the next example, right here, is this passive or active? This is passive because the characters are appearing in first and third quadrant, right? So next one, linear and non-linear. So bilateral you can say that the characters are linear because it is a straight line and passing through the horizon. And last one is bilateral and unilateral. The characters in the positive direction is same and the negative direction also same, sir. Then we can say that passive and linear and bilateral, right? So coming to the third example, here I mentioned, okay. So is this passive or active? So blindly we can say that it is passive, right? Coming to the next one, linear or non-linear. So you cannot define only by seeing this, okay. So total characteristics you have to mention, okay. You have to clearly mention the total characteristics, okay. We have to see total characteristics, okay. So this is a linear or non-linear? This is a non-linear because the characteristics are not a straight line throughout the characteristics, okay. So this is non-linear. Is this bilateral or unilateral? In the positive direction the characteristics are like this, and in the negative direction the characteristics are different, okay. So then it is passive and non-linear and unilateral. And lastly, here I mentioned the characteristics are second quadrant and fourth quadrant, right? So the characteristics are active or passive? Active. Blindly we can say that active, right? Linear or non-linear? So we can say that it is a linear because the straight line passing through the horizon, right? So lastly, bilateral and unilateral, the characteristics are same or different, right? So in the positive direction this is negative, right? This is negative direction, the characteristics are same for also in the positive direction also. So then the characteristics are same in the either the direction, so then we can say that it is a bilateral, right? So we can define the characteristics for the following elements like this, okay. Okay, thank you. We can discuss in the next topic in the next video, the energy sources, okay. Thank you.